All right, today we're looking at assignment 8.3 using normal distributions. And it says, one of the most common examples of a normal distribution is the distribution of scores on standardized tests such as the ACT. In 2010, the mean score on the ACT was 21 and the standard deviation was 5.2. So notice they gave us that the mean is 21 and that the standard deviation is 5.2. Use this information to sketch a normal distribution curve for the ACT. So remember that when we sketch the normal distribution, we have to start with our middle line right here, smack dab in the middle. And that's going to represent our mean, which in this case is 21. Then, remember, we go 3 lines up, and we go 3 lines down. And remember, it's always 3 lines up and 3 lines down every single time. So here's my normal curve looking something like this. And remember, to get each line, I'm just going to add my standard deviation of 5.2. So I take my mean of 21 and I add 5.2, which gives me 26.2. If I add 5.2 again, I get 31.4. And if I add 5.2 again, I will get 36.6. Heading down, now I'm going to subtract the 5.2. So if I take 21 and subtract 5.2, that gives me 15.8. And then I can subtract 5.2 again, which will give me 10.6. And I subtract it a third time and get 5.4. Now once I have that normal curve drawn, now I can go ahead and fill in the percentages. And remember, we learned on our last assignment that if something is normally distributed, the percentages will always be the same. So that means that we know that 34% of our data falls in here, and 34% of it is right here. We know that 13.5% of it falls in on these two sides. And then we have 2.35% of it. And then we know that these little tails each hold 0.15% of our data. And now that I have that filled out, I can go ahead and answer these questions. So notice the first question asked, what percentage of students scored below 21? So here's my 21 right here. And I want to know what percent of students scored below 21. Well, I can actually see by looking that that's half the curve, or 50%. But if I didn't know that, I could also figure that out by adding the 0.15% plus 2.35% plus 13.5 plus 34. And if I add those together, it should equal 50% of the data. So then I know that 50% of students got a score lower than 21. Well, once I know that, I can go ahead and answer some of these, and I'm going to let you go ahead and answer problems 2 and 3. But look at problem 4, which says find the z-score for each ACT test score below. And then I gave you here the formula for the z-score. So when we talk about scores or ACT tests, well, if you look at these scores, not everyone on the test scored a 21 or a 26 or a 31 or a 36. Sometimes people get scores that are in between. For example, what happens if I get a 24? Well, I know that if I scored a 24, I'm falling somewhere in between the 21 and 26. But if I want to know what percentage of students I outscored, well, it's going to be hard because I don't know how much of this 34% right here is lower than me and how much is higher than me. So when I can't figure that out, I have to find what we call a z-score. And a z-score is actually a standard deviation. It tells me how many standard deviations I am, either above or below the mean. So this z-score is how many standard deviations my score is, either above or below the mean. And once we know what our z-score is, or in other words, once we know how many standard deviations we are, either above or below the mean, we can use that information to figure out what percentage of students scored either higher or lower than we did. So let's say, for example, that I took the ACT and my score was 23. Well, if you look up here, a 23 is going to be somewhere in here, somewhere in between 21 and 26, but I'm not exactly sure where, and I want to know exactly where. So to do that, I'm going to use this z-score formula. Now in this formula, the x is my score, which in this case was a 23, minus mu. Do you remember that symbol? It means the mean. And in this case, remember the mean was 21. All over sigma, or the standard deviation, which was 5.2. So now I'm going to type that into my calculator. 23 minus 21 divided by 5.2. So in my calculator, I put 23 minus 21 in parentheses, and then I'm going to divide that by the standard deviation of 5.2. And my calculator tells me that it is 0.38. So then I know that I am 0.38 standard deviation higher than the mean, which makes sense because look right here at this picture where 23 is. Can you see how it's about 0.38 above 21? It's not quite a full standard deviation. It's about 0.3 of a standard deviation. So once you know that, I'm going to let you go ahead and find the rest of the z-scores here on this first page. Once you've done that, tune into my next video and I'll show you how to do the second page.